So today we are summarizing our last subtopic on chlorine and its compound. And after that subtopic, we shall straight away go on revision. We shall revise for the remaining time as we wait for what is going to happen. If possible, God knows, we shall go back, maybe on 15th, we shall go back and prepare for our final exams. We are going to summarize chlorine and its compound. And the next time we shall be meeting, we shall basically do revision. Revision in whatever was taught in senior 1, senior 2, and then senior 3. The topics that are remaining, when we report back, those topics will be covered. Those topics will be covered because there are around 3 topics that are remaining for everything to be completed. So let us look at our last on chlorine and its compound. And our last, we are going to see, we had started on hydrochloric acid. We had done hydrochloric acid. We're doing hydrochloric acid, and we had looked at its preparation on a small scale, its preparation on a large scale. We had looked at some of its physical properties, and last week we also started on some of its chemical properties. And if you can remember very well, for some of you have been very keen, we looked at chemical property 1, and chemical property 1 was its reaction with carbonates or hydrogen carbonates. And I told you that chemistry is one of the subjects, it's one of the science subjects that is very, very easy for students who are bright. The funny bit with chemistry, you don't have mediocres. You either know what you're going to write or you don't know. Because if you're mediocre around there, you will not get anything. So you either know what you're going to talk about and what you're going to write, or you don't know. So that is the only good thing about chemistry. And for the bright guys, for the bright students, they find chemistry to be very simple. And most of them, when you try to talk to them, they'll always tell you chemistry is a reducing agent. A reducing agent whereby you don't need to spend a lot revising it if you understood the concepts very well. So last week we did one of the chemical properties of hydrochloric acid, and we said like any other acid, like any other dilute mineral acid, it will react with carbonates or hydrogen carbonates to give you a corresponding salt plus carbon dioxide and then plus water. And that chemical property took us back to one of the examples, to one of the numbers that I left you people to do. And when we tried to analyze that question, it needed you to know that chemical property. Chemical property too, like any other acid, like any other mineral acid, in aqueous state, it will react with bases to form a salt and water only. And I remember in senior 1, your teachers used to say, when an acid reacts with a base, what do you form? You form a salt and water only. And what type of a reaction is that? And your teachers used to emphasize that is a neutralization reaction. An acid, a dilute mineral acid, reacts with a base to form a salt and water only. And your teachers really emphasized it, that type of a reaction is a neutralization reaction. So we are going to look at that chemical property. And I told you, still from your senior 1, we are building on, still from your senior 1, we remember we said, what is a base? And you remember you said, a base is a substance, a base is a compound that when dissolved in water produces hydroxyl ions or hydroxide ions as the only negatively charged ions. That is when it is dissolved in water. But remember, we said a base can be a metal oxide or it can be a metal hydroxide. But when you dissolve them in water, you're going to form a compound, which compound will ionize to give you only and only hydroxide ions as the only negatively charged ions. And some of you, even your teacher has simplified it further and said a base is a what? A base is a proton acceptor. A proton acceptor, because the hydroxide ions will react with the proton to form water. And we said, remember, whatever you're doing, whatever you're going to write down, please, you must know the general statement. How does it behave? How does it happen? Okay, and remember, those are our general statements. But when it comes to observation, we don't write the general statements. We state the color and the state of what is being formed, and the color and the state of our reactants. Therefore, hydrochloric acid, like any other mineral acid, okay, it also reacts with what? It reacts with bases to form a salt and water only. And sometimes they'll give you maybe hydrochloric acid in aqueous state, and then they'll give you a given base. Then they will tell you to write the observation, write the equation, and then they may go further to say, name the type of a reaction that occurs. That type of a reaction is what we term as a neutralization reaction. So I'm just giving examples. For example, if I had what? If I had copper 2 oxide being reacted with what? Being reacted with dilute hydrochloric acid. And what am I supposed to form? I'm supposed to form a salt which is copper 2 chloride. Plus what? Plus water. Plus water. So that is what I form. And I told you, however neat your chemical formulae or chemical symbols are, without balancing the equation, it would be a wastage of what? A wastage of time. Therefore, let us try to balance our equation. We shall balance our equation by multiplying or by putting a 2 on hydrochloric acid. And when you try to see it, now our equation is balanced. So this is our base. This is our acid. We are forming a salt and water. And such a reaction is a neutralization reaction. Please remember, they may tell you to write the observation. Remember, copper 2 oxide is black in color. It's a black solid. Hydrochloric acid is a colorless liquid. And this copper 2 chloride is what? Copper 2 chloride is blue. Therefore, it's a blue solution. And then our water is a colorless liquid. Therefore, what do you observe? You observe that a black solid dissolves in a colorless solution to form a blue solution. The color of water, since it's colorless, it will be masked. It will be shadowed by what? By the blue color of copper 2 chloride. That is an example of a base whereby you're using a metal oxide. But you can use a metal hydroxide. And in the metal hydroxide we can use, let us use the ones that are very common, the ones that we meet in our practicals, and that is, let us look at sodium hydroxide. What would happen if we had sodium hydroxide? That is sodium hydroxide solution plus our hydrochloric acid. And what shall we form? We shall form sodium chloride, still plus what? plus our water. Okay, let us try to balance the equation. How shall we balance the equation? We have one sodium atom here, the other side also one. We have one oxygen atom, even the other side there. We have two hydrogen atoms, even the other side there too. Chloride atoms, we have one, even the other side it's one. Therefore, our equation is balanced. So those are some of the examples under which we can say that bases react with this hydrochloric acid to form a salt and water only, and the type of a reaction undergone here is called a neutralization reaction. Therefore, they may ask for the type of a reaction. Even here, they may ask for the observation from our qualitative analysis, or even from our quantitative analysis. We have been using sodium hydroxide. Maybe you're not gotten a chance to look at it, but at least by a mere fact you start on any practicals that is either in quantitative or qualitative, okay, you must have met this man here, sodium hydroxide. And sodium hydroxide is a colorless solution. Even here, colorless. Even this one here, colorless. Even here, colorless. Therefore, what do you observe? You simply observe a colorless solution. So there, you know what you would talk about. The type of a reaction is a neutralization reaction. And the senior fours there watching, or the senior threes, even a senior one here, a very sharp senior one would do this number. So a very sharp senior two would do this number because the senior ones were doing a different curriculum. Even a very sharp senior two would do such a number. The third chemical property, like any other mineral acid, this acid also reacts with metals to form a salt and hydrogen gas. I remember I told you that its reactivity with metals, you must look at the position of the metal in what we term as the reactivity series. Okay? Those that are placed at the top of the reactivity series are very, very, very reactive, or their reaction is very, very violent. Therefore, we don't normally use them. We use those that are moderately reactive, but those that again are below hydrogen cannot be used. Okay? So we shall look at the metals that are in the middle of the reactivity series. How do they behave with dilute hydrochloric acid? They will still form a salt plus hydrogen gas. And that is one way of preparing hydrogen gas, by reacting metals with any acid, any dilute mineral acid. You can use sulfuric, you can use nitric, you can use hydrochloric. But again, with nitric, there are metals that can do so. Even with sulfuric, there are metals that can do so. We cannot use calcium with dilute sulfuric acid, simply because the compound you form, the salt that you form, is insoluble. Calcium sulfate is sparingly soluble. Therefore, since most of it does not dissolve, what does that mean? It prevents further reaction, further evolution of hydrogen gas. Therefore, even with those other acids, you must know how they behave with those metals. So let us give an example. Our chemical property 3, reaction with what? Reaction with metals. Reaction with metals. And the metals we are going to talk about, one, we shall talk of magnesium, we shall talk of iron, we shall talk of calcium, okay, we shall talk of zinc, and so on, etc. Okay? And when we look at those metals there, those metals are somewhere there in the reactivity series, apart from calcium, which is somewhere at the top of the reactivity series. But these other this, and this. Okay. For them, their reactivity is moderate. Therefore, when you're carrying out such a reaction, you don't expect it to be very violent. Therefore, it can be moderately carried out, even in a laboratory setting. So, let us see, what do you form? What do you form when dilute hydrochloric acid reacts with magnesium? If it reacts with magnesium, okay, what do you form? You're going to form magnesium what? Magnesium chloride. Magnesium is more reactive than hydrogen. It displaces hydrogen, and therefore, after it has displaced hydrogen, it reacts with chlorine to form magnesium what? Chloride. And then plus what? Plus hydrogen. And I always task my students, to always ask where they have not gotten right. Okay? I've told you this magnesium is more reactive than hydrogen. Therefore, it can ably displace hydrogen from hydrochloric acid, and then it will recombine with it to form magnesium chloride. Therefore, what are you left with? You're left with hydrogen ions. But remember, when hydrogen is alone, it exists as a diatomic molecule. That's why we are writing it as what? H2 instead of just writing H. And remember, when it is not combined with anything, it is a gas. And our gas is our hydrogen gas. Please balance the equation. Always and always balance the equation. And when you try to balance the equation, you will simply put here a 2. Our equation will be balanced. Therefore, that is our equation. The first type of reaction we looked at was a neutralization reaction. This type of a reaction is not a neutralization reaction. You're forming a salt and hydrogen gas. But this type of a reaction is called a displacement reaction. Please quote that right. That is a displacement reaction. And what is the principle? What is the principle behind displacement reactions? What is the principle behind displacement reaction is that for you to displace any other element from its compound, you must be more reactive. Either you're more electropositive or more electronegative. It's like in real life. If you're to have a fight, the one who is less energetic will always be beaten. The one who is more energetic and more powerful will always what? Win the battle or win the fight. So with a displacement reaction, if you're less reactive than that element, you can never displace it. You can never displace it from its solution or from its compound. So here, this type of a reaction is a displacement reaction. This was a neutralization reaction. Why am I giving that? In senior when you look at some of the questions in paper 2, they'll give you chemical formulae or chemical compounds. They tell you to write, state what is observed, and they may go further to say, right, name the type of a reaction that occurred. This is the displacement reaction. And what is also very common here with displacement reactions, they always tend to confuse students by telling them to write ionic equations, not molecular equations. This is a molecular equation. But the examiner may go further and say, please write an ionic equation. And I told you, me as a teacher, I can ably write an ionic equation minus first writing it somewhere. But you as a student, if you really don't know what you're going to write as an ionic equation, it is always advisable, please, this is paper 2, whereby you're presented with answer booklets, okay? Write that ionic equation at the back of that answer booklet. First write the molecular equation, form ions from there, and start cancelling out the ions that are the same on either sides of the equation. Please, you remain with what we term as an ionic equation. But me, when I'm teaching students who are sharp, I always tell them, if it is an acid, always from an ionic equation for the acid, you only pull out hydrogen ions. But if I'm teaching our moderate learners, I always tell them, please, first write the molecular equation, form ions from there, start cancelling out ions that appear to be, that are similar on either sides, and then what you're left with is what we term as an ionic equation. Therefore, since we are teaching everyone, let us try to form an ionic equation from this molecular equation. If the question has come and it is very specific, please write an ionic equation. However neat your molecular equation will be, you will not score any mark. But if the question comes and it is just open, write an equation that took place. Please, whether you write the ionic equation or the molecular equation, any you write, you will score your marks. But if the question has been very specific, please write the ionic equation. Please never waste time with the molecular equation. So our ionic equation, and I've told you most times with all the displacement reactions they are going to ask about, if they're to ask about a displacement reaction, what always follows, they will always tell you to write the ionic equation. So let us write the ionic equation from this molecular equation. Our magnesium, since it is in solid state, remember we said we don't form ions in solid state, we don't form ions in gas state, and then we don't form ions in liquid state. When do we form ions? We only form ions either in molten state or in aqueous state. Okay, therefore this one will remain as magnesium. But our hydrochloric acid, what do we have? We have 2 hydrogen ions. Plus what? Plus our 2 chloride ions. Giving us what? Now this magnesium here, magnesium chloride, now it can form ions because it is in aqueous state. Remember, I've told you, when do we form ions? We form ions in aqueous state or in molten state. The senior fours, by the time you left school, for some schools, you're done electrolysis. And you know what I mean by molten state. In molten state, you get a solid and then you heat it. Then it is in that form of semi-solid or semi-liquid. So this will give us magnesium ions. There are 2. It's 1, but magnesium has a valency of 2, plus our what? Plus our 2 chloride ions, plus our hydrogen gas. It will not form any ion because remember we are saying we are not forming ions in gas state. Therefore, when you look at that equation, we try to cancel whatever looks the same. What looks the same? We have the chloride ions and then our chloride ions this side. But that is your side work. Please don't show us this because for us, by the time we are marking, we know what we are talking about. Please don't show us that. Therefore, our ionic equation will be what? Will be magnesium, okay, plus what? Plus 2 hydrogen ions, giving us what? Giving us magnesium ions, plus what? Plus our hydrogen gas. How do you tell that you're indeed correct? We have the charges must always balance. we have a total charge of +2 this side. Even here we have a total charge of +2. Magnesium 1, magnesium 1. Hydrogen 2, even the other side there are 2. Therefore, our ionic equation is balanced. Please practice to write ionic equation. Whenever you're given molecular equations, go back after the teacher has left and look at the ionic equation, because sometimes the questions come whereby they're very strict. Please write the ionic equation. That is our ionic equation. Okay, and that type of a reaction is a displacement reaction. And what is the most common question still on a displacement reaction? Most times they'll give you a metal which is below hydrogen, and in all the cases there is no it can displace what? Hydrogen. And I saw this last year whereby students were given copper. Okay, they were given copper, that copper was reacted with what? Let me this time around use hydrochloric acid, because it's the one I'm dealing with, okay, which is a mineral acid. And they told the students to write the observation, to write the equation, and then to explain the observation. What do you observe? Remember, that is our copper plus our hydrochloric acid. Okay? But from our reactivity theory, copper is just below hydrogen. Therefore, copper can never displace hydrogen. Therefore, when it comes to observation, when it comes to equation, no reaction. When it comes to observation, no observable change. When it comes to explanation, okay, when it comes to explanation, what will be our explanation? What will be our explanation? Our explanation will be as follows. Okay? Copper is less reactive, or copper is less electropositive than what? Than hydrogen. Okay? And therefore, it cannot displace hydrogen from its solution, which is what? But the solution here was what? Hydrochloric acid. Okay, so that is the explanation. This was our observation, and this was our equation. Why have I written them down for you people? Because some students really knew what they're talking about. They knew that no reaction, but they left it as blank space. Please, when you leave it as blank space, you will not score the mark, because a mark will be awarded there. So who are those students who scored marks? When it came to equation, they came and showed us the the reactants. But when it came to the side of the products, they told us no reaction. When it came to observation, what do? No observable change. Indeed, it remained the way it was. Then they came and then explained why you had no observable change or why there was no reaction. It's simply because copper is less reactive or less electropositive. Remember that from senior 2, our reactivity theory, our electrochemical theory. Copper is just below hydrogen. And with that, chemical reactions of copper, chemical reactions of hydrochloric acid. Chemical reactions of hydrochloric acid are done. What are we left with is what we are going to do in the remaining time. How do we test for? Test for chloride ions. And one would ask, again, why are we testing for chloride ions? Remember, our topic was basically chlorine and its compound. And in chlorine and its compound, chlorine forms chloride ions. Therefore, how do we test for chloride ions? Okay, chloride ions can be in solid state. We can have the chloride ions when a compound is in solid state, or we can be given a solution. Therefore, we shall see how would we test them when they're in solution, and how would we test them if they're in a solid. Okay, if they're in a compound which is in solid what? State. Therefore, we must know what we term as reagent. In chemistry and then in biology, we talk of reagents. So we must know the reagents that we use. And every time that you're asked to name the reagent, please never write the chemical formulae or chemical formula, and never write the other name of that reagent. Write the accepted chemical name. Okay, so we're going to look at what reagents do we use to test for these chloride ions if the chloride ions are in solution. What? In solution, they're in solution. So if you're provided with a solution, if a solution contains chloride ions. Okay, how do you really prove that indeed this solution contains these chloride ions? There are reagents that we are going to use. One, we shall talk of dilute nitric acid, and then silver nitrate solution. Silver nitrate solution. This is a combination of two solutions but forming one reagent. Dilute nitric acid and then silver nitrate solution. Of course, one would ask, why are we using dilute nitric acid? We shall see in our practical that dilute nitric acid, whatever you're going to form with nitric acid, you're going to form salts that are nitrates. And remember, from your senior 1 or senior 2, you talked of all nitrates being what? Soluble. If we are to use dilute sulfuric acid or dilute hydrochloric acid, the possibility of some of the salts coming out when they are precipitates. For example, with sulfuric acid, we would form maybe lead 2 sulfate. would form barium sulfate, okay, which is insoluble. Maybe if we had used hydrochloric acid, we would form lead 2 chloride, which is also insoluble. So we are using dilute nitric acid, and then we are also using silver nitrate solution. And if that solution indeed contains chloride ions, what do you observe? You observe. So what would be your procedure? This is like a practical. What would be your procedure, okay, to a solution containing chloride ions, okay? You're going to add how many drops? You're going to add 2 drops of dilute nitric acid, okay? Followed by maybe 1 centimeter cubed of silver nitrate solution. And what do you observe? You observe a white precipitate. A white precipitate of what? A white precipitate of silver chloride. Why a white precipitate of silver chloride? Remember, we said at your level, we said all chlorides are soluble apart from silver chloride and then lead 2 chloride. Therefore, from silver nitrate and dilute nitric acid, for us, what are we interested in? We are only interested in the silver ions. Therefore, it is the silver ions that react with the chloride ions to form silver chloride. What will be our equation? Like, our equation will be, we pull out silver ions from our silver nitrate solution. And then we also get our chloride ions. To give us what? To give us silver chloride, which is a white precipitate. Okay? Sometimes they may go further, that after you formed the white precipitate, they will tell you add drop-wise until in excess ammonia solution. And once you formed the white precipitate, but when you add ammonia solution or aqueous ammonia, and then you form a colorless solution, it means that the white precipitate dissolves to form a colorless solution. It means that indeed that solution contained chloride ions. Therefore, to this white precipitate, to the white precipitate, add aqueous ammonia drop-wise until in excess, okay? Once you form a colorless solution, it means that indeed your solution contained chloride ions. Therefore, what will be our observation? Our observation would be our observation will be the white precipitate dissolves to form a colorless solution. And this is one way we confirm that indeed chloride ions were present. They may tell you even to write the equation. What will our equation be like? Our equation will be, we have our white precipitate, which is silver chloride, We are adding excess ammonia. And what do we form? We form a complex, a colorless complex, and that complex is called diaminosilver ions. Therefore, we shall have our silver, our ammonia, plus our chloride ions. Okay? So that complex is called diamine silver ions, and that is a colorless solution. Please don't forget the charge. That is our charge, and that is our charge. So that is our complex diamine or diaminosilver ions. Okay? And that is one way we confirm that indeed our solution had chloride ions. If you add dilute nitric acid followed by silver nitrate solution, you get a white precipitate. But to that white precipitate, when you add aqueous ammonia dropwise until in excess, you see that. What do you observe? You observe that the white precipitate dissolves to form a colorless solution. What is the equation? The equation is that our white precipitate, we added ammonia, and we are forming this complex which is diamine silver ions, and that is what we form. A question may come to explain your observation. Explain your observations and then write the equation. Here, the white precipitate is due to formation of silver chloride, which is insoluble. Here, the white precipitate dissolving to form a colorless solution is due to formation of this diamine silver ions, which is soluble. They may tell you to explain your observation. So that is one way. One way we test for chloride ions by use of dilute nitric acid and then silver nitrate solution. If you get a white precipitate and to that white precipitate you add ammonia and the white precipitate dissolves to form a colorless solution, it will mean that indeed your solution had chloride ions. Sometimes it is interchanged, whereby they will say to a solution suspected to be containing chloride ions, add silver nitrate solution and then dilute nitric acid. There, whenever you're stating the observation, what would you state? They have started with silver nitrate and then dilute nitric acid. Okay? So you will tell us a white precipitate which is insoluble in dilute nitric acid. If they had started with silver nitrate and then followed by what? And then followed by dilute nitric acid. Here you started with dilute nitric acid and then you followed it up with silver nitrate solution. Okay, that is reagent 1. Reagent 2, still it is a combination of compounds. We shall have dilute nitric acid and then lead 2 nitrate solution. And this is a conditional reagent. And then do what? And then warm. Okay? Dilute nitric acid and then lead 2 nitrate solution and then you warm. Okay? To a solution that contains chloride ions, what do you observe? You observe a white precipitate of lead 2 chloride. which dissolves to form a colorless solution on warming. Because lead 2 chloride is insoluble. But when you warm it, it dissolves. Therefore, you'll form a white precipitate. But when you warm it, that precipitate will dissolve to form a colorless solution. But again, on cooling, the white precipitate will reappear. But that's why we are saying it is a conditional reagent. We are using dilute nitric acid, lead 2 nitrate solution, and then we are warming. So what do we observe? Still, you'll use 2 drops. You may also use here like 1 centimeter cubed. And then you observe. After you've observed, what do you find? You find the white precipitate, which dissolves on warming. Therefore, our observation, if that solution contained chloride ions, it would be a white precipitate of what? Of lead 2 chloride, okay, which dissolves to form a colorless solution on warming. Okay, and in some theory papers they will say a white precipitate which dissolves but reappears on cooling. It means they're talking about the same thing. They're talking about lead 2 chloride. It is soluble on warming, but it is insoluble on cooling. That's why some books will say a white precipitate, okay, which dissolves to form a colorless solution, but reappears on cooling. So they're referring to lead 2 chloride. Okay, then remember all what we are interested in here. You may write the molecular equation, but what we are interested in, we are using lead 2. It means lead 2 nitrate. It means that we are only interested in what? Lead 2 ions. And our solution contains chloride ions. Therefore, our equation we shall have our lead 2 ions from lead 2 nitrate plus our chloride ions in solution giving us what? Giving us lead 2 chloride. Okay, we balance the equation, and this is our white precipitate. And this is our lead 2 chloride. Okay, so they may ask for the observation, they may ask for the equation, they may also ask you to explain. So they'll ask you to explain. You'll explain that lead 2 chloride formed is insoluble on cooling, but it is soluble on warming. That's why the white precipitate finally forms a colorless solution. So we have looked at how many reagents? We have looked at basically 2 reagents. Dilute nitric acid and then silver nitrate solution. We have also looked at dilute nitric acid and then ready to nitrate solution. And then you warm. Please, please, always be sharp, because next time, here we have used the combination of reagents. Next time, they may say theoretically or practically, they may also say it, to a solution, add ready to nitrate solution. State what you observe. And then you say, no, madam said it must be with dilute nitric acid. Please, if it has come and I've not given you dilute nitric acid and I've given you only ready to nitrate solution, you will still have the same observation. Don't forget that. But if it has come and you're writing the reagents yourself as a student, please always be sharp so that you don't have, the examiners don't have any benefit of doubt. Write the correct thing. And what is the correct thing? Is dilute nitric acid and then ready to nitrate solution and then you warm. Or dilute nitric acid and then silver nitrate solution. And what do you observe? Okay? And if it has come in paper 2 and you're writing, maybe that given that set a number on chlorine, maybe hydrogen chloride, or maybe hydrochloric acid, and they're saying, briefly write how you would test that a solution contains chloride ions. Please show the examiner that you know. How are you going to show the examiner that you know? By writing the procedure. After you've written the procedure, write for the examiner the equation. After you've written the equation, maybe before even you write the equation, write the observation. Procedure, observation, and then equation. You really show the examiner that indeed you are taught. Okay? If it is chloride ions and you're writing a test procedure for yourself, show the examiner that you really know what you're talking about. To a solution containing chloride ions, add 2 drops of dilute nitric acid. Followed by what? Followed by maybe 1 centimeter cubed of silver nitrate solution. Observation, a white precipitate of silver chloride. Please, even if you don't write silver chloride, a white precipitate is formed. And then go further, write for that examiner the equation. Okay, write the equation. Okay, whenever you're forming precipitates, it's because that salt is insoluble. Whenever you're forming solutions, it means that that salt now is what? Soluble. Those solutions may be colored or they may be colorless. So sometimes they even ask you to explain your observation. The white precipitate of silver chloride is simply because it is insoluble. The colorless solution of diamine silver ions is simply because the salt that has been formed is soluble. That's why you form that colorless solution. Please show the examiner that you know what you're talking about. Okay? So, I think I've done my best. I've done my best at your level. I've done my best at your level, but I'll leave you with a question. When we meet, we shall look at something else. When we meet, we shall look at something else. We shall look at something else, and before we look at something else, we shall also do. How would we test for chloride ions if you're presented with a solid containing chloride ions? They are like the way we looked at preparation of hydrochloric acid. To that solid, you will simply add conc sulfuric acid and then warm. So we shall see that. So our number, which is only going to be only one number. Our exercise will be dilute hydrochloric acid has reacted with sodium with this with led to nitrate solution. Okay, you write the observation, explanation, and then the equation. Please do that. It's because of time that I'm rushing. My WhatsApp number is that. Please, that's why you will send all your work. It has been so wonderful to teach you. I want to thank BBS so much, and I also want to thank Maryland High School so much. May the dear Lord bless you abundantly.
Somera Muddiiro lyo ng'ewagiddwa bw'osomeseza omwana wo mu masomero ga Giant Schools.